Hello everyone, welcome all to Physics with Aeronautics. So in this video we will discuss about some basic formula of moment of inertia and center of mass. So let's begin. So what is center of mass? This is the point at which the whole mass of an object concentrated. So let's take a body. This is a body A, and here this is a point X where the whole mass to be concentrated. So here we can say that this is the center of mass of this body. So when we represent it through the position, we can write it as RCM is equal to summation over MI whole divided by summation over MI. And when we represent it through the coordinate system, we can write it as RCM is equal to XCM I cap plus YCM J cap plus ZCM K cap. And for continuous system, we can write XCM is equal to summation over dm x1 plus x2 plus x3 up to xn whole divided by summation over dm, that is equal to integration of x dm whole divided by integration of dm. Similarly for ycm uh, is equal to integration over ydm by integration over dm, and zcm is equal to integration over zdm by integration over dm. Now come to the mass density. Here linear mass density lambda can be represented as dm by dl. Surface mass density sigma can be represented as dm by dA, and volume mass density rho can be represented as dm by dv. So the center of mass for velocity and acceleration can also be represented as vcm is equal to summation over mibi whole divided by summation over mi, and acm is equal to summation over miai whole divided by summation over mi. Then come to the moment of inertia. So the tendency of an object to keep its states of rest or motion is generally defined as moment of inertia. If a body is moving, then the moment of inertia will keep it moving, and if it is at rest, then it will keep it at rest. So the formula for it is I is equal to summation over mi ri square. Here ri is the perpendicular distance. So for continuous system, the moment of inertia can be represented as integration over dm ri square. So how to find moment of inertia? So let this is a body. So know the axis of rotation. First of all, we will consider that which will be our axis of rotation. Then take axis of rotation passing through the origin. Let consider that this axis of rotation is passing through the origin. Then consider dm anywhere. Uh, then we will consider a small mass dm anywhere over the object. Then measure the distance of dm from the center of mass, that is considered to be x. So the distance from the center of mass to dm will be x. Then integrate with proper limit according to the formula. So by this formula, we will integrate it with the proper limit. Then there are two theorems. First of all, parallel axis theorem, and second one is perpendicular axis theorem. So the parallel axis theorem says that I is equal to ICOM plus mx square. So here I represent the moment of inertia of parallel axis, that is the moment of inertia over here, and ICOM is the moment of inertia about center of mass, that is the moment of inertia about this axis. And here x is the distance of parallel axis from center of mass, that is this is the distance between the parallel axis and the axis passing through the center of mass. Then our next theorem is perpendicular axis theorem. Here x and y axis are present at same plane and z axis is perpendicular to the plane. So let here is our body, and here this ix and iy are the two axes that are present at the same plane, and here iz is perpendicular to both of these axes. So here we can write it as Iz will be equal to Ix plus Iy, where Iz is the moment of inertia about perpendicular axis and Ix and Iy are the moment of inertia about the axis x and y that are present in the same plane. Then moment of inertia of rectangular lamina. So here Ix is equal to ml square by 12. That is the moment of inertia about this axis. Then Iy is equal to mb square by 12. Here about this axis the moment of inertia is mb square by 12, and here Iz is equal to m l square plus b square by 12. This is the moment of inertia about the axis passing through the perpendicular plane Iz. And here L is the length of this rectangular lamina and B is its width. Then moment of inertia of rod. So the moment of inertia about the center of mass of a rod can be represented as ml square by 12, where L is the length of the rod. Then moment of inertia of ring. So Ix is equal to mr square by 2, where Ix is the axis passing through the center of mass and lying on the plane. Then Iy is equal to mr square by 2, that is the axis passing through the center of mass and lying on the plane. Then Iz is equal to mr square, where the axis is perpendicular and passing through the center of mass. So through this axis, this is mr square by 2. For this axis, this is mr square by 2, and the axis Iz that is perpendicular to the plane is mr square. Then for disk, the moment of inertia will be Ix equal to mr square by 4, that is present at the plane. Iy is equal to mr square by 4, that is the axis lying on the plane and passing through the center of mass. Then Iz is equal to mr square by 2, where the axis is perpendicular and passing through the plane and also center of mass. So let's discuss about the moment of inertia of hollow cylinder and solid cylinder. So for hollow cylinder, the axis passing through its own axis will be equal to Ix is equal to mr square. That is, we can relate it with the moment of inertia of a ring about its perpendicular axis. Also, Iz is equal to ml square by 12 plus mr square by 2. This is the axis passing through the perpendicular and through center of mass. Also, we can conclude it as the combination of a moment of inertia about the diameter of a ring and the moment of inertia of a rod. So here R and L represent the radius and the length of the cylinder. Then moment of inertia of solid cylinder. So for solid cylinder, Ix is equal to mr square by 2, which is equal to the moment of inertia of disk about its perpendicular axis. Then Iz is equal to ml square by 12 plus mr square by 4, where we can relate it with the moment of inertia of a rod and a disc about its diameter. So here R is the radius and L is the height of the solid cylinder. Then moment of inertia of hollow sphere. So the moment of inertia of hollow sphere about its center of mass can be represented as 2 mr square by 3. Here R is the radius of the sphere. Then moment of inertia of solid sphere. Here moment of inertia about the center of mass of a solid sphere can be represented as 2 mr square by 5, where R is the radius of sphere. Then moment of inertia of annular disk. So here this is annular disk, where A is the radius of inner sphere, where B is the radius of outer sphere. So the moment of inertia about the center of mass can be represented as m by 2 b square plus a square. Similarly, for annular solid cylinder, the moment of inertia about the center of mass can be represented as m by 2 b square plus a square, where b is the radius of the outer cylinder and A is the radius of the inner cylinder. So let's come to the radius of gyration. So radius of gyration that can be represented as k is equal to root over of I by n, and it depends on the axis of rotation through which it is we are calculating the moment of inertia. I hope you all enjoyed the session. So for more videos, please do like, share and subscribe. Thank you.